ሰላም ተማሪዎች እንደምን አላችሁ? እኔው ነኝ የአስረኛ ክፍል ፊዚክስ መምህራችሁ ከሉሲ ብሪጅ አካዳሚ። ዛሬ የምንመለከተው ሴክሽን 1.2 ቬክተር ሪፕሬዘንቴሽን ይሆናል ማለት ነው። ከዛ በፊት ግን lucyBridgeacademy.com በመግባት ሾርት ኖቶች፣ የጥያቄ ባንኮች እንዲሁም ከ5 በላይ ቋንቋ መረዳት የሚችል AI አሲስታንስ ፐርሰናላይዝ መተግበሪያ ማግኘት ይችላሉ። በተጨማሪም የዩቲዩብ ፔጃችንን ሰብስክራይብ እያደረጋችሁና የቴሌግራም ቻናላችንን ጆይን እያደረጋችሁ ወይም እየተቀላቀላችሁ ሐሳብ አስተያየታችሁን አጋሩን። ወደ ትምህርታችን። What distinguishes scalar quantities from that of the vector quantities? What distinguishes scalar quantities from the vector quantities in physics? በፊዚክስ ውስጥ ስካላር እና ቬክተር ኳንቲቲዎችን የምንለይበት መንገድ በምንድን ነው? Let's see that by having that of our definition. The first question says about what? The scalar quantities are quantities. Scalar quantities are quantities that describes only magnitude. Are quantities that describes only magnitude. And that of it is only magnitude, which means by that the magnitude which describes that of what? The number of quantity and the unit. So in such a way, for example, you can give an example like that of what? Mass, length, time, temperature, energy, such as the mass, which is measured having that of the SI unit kilogram, and non-SI units like that of gram, milligram, ton, and any other. So by having this, the mass like that of the mass, which is equals to what? 2 kilogram. 2 kilogram. This means what? 2 the quantity, and the kilogram is the scale of measurement. Whereas the length is which equals to what? 8 kilometer. 8 the quantity. Kilometer, which is what? The non-SI unit of the length measurement. Non-SI unit, or the unit that we use to measure what? The length of a given distance. Time, T which equals to what? 5 seconds. Temperature, the temperature of a normal body temperature of human being is around a maximum of around what? 37 degrees Celsius. Around 37 degrees Celsius. Energy, either in calorie or joule. But here the joule is in the SI unit, whereas the calorie is non-SI unit, the converting unit, like that of 4.2 joule. 4.2 joule. Like this, we have what? We have a given scalars. Whereas when we come up on vectors are quantities that can be described in both magnitude and direction. Okay? Here, when we think about the difference of this scalar and vectors, scalars are independent of direction. Whereas vectors are what? Dependent of direction. Vectors are dependent of direction. Okay? Dependent of direction, like that of velocity. The velocity. V, which has what? An arrow at its overhead on that of the symbol of the vector velocity. Force. That it has what? a vector force, which has what? An arrow on its overhead. So by having these are the basic difference on that of what? Scalars and vectors. Scalars and vectors. Scalars and vectors. So by having this, like that of what? The velocity which is measured having that of what? The velocity which is measured having that of 20 meter per second east. 20 meters per second east. Here the magnitude and also what? Here it is the direction. The east. Here the force of a given body which is applied 100 Newton to the right. 100 Newton to the right. Here it is 100, then Newton to what? The right. So by having this, such kind of forces, momentum, impulse, acceleration, electric field, which are what? The quantities, what we call it? Vector quantities. When you learn the other quantities in the higher level, in grade 11, grade 12, and in the college or university level, you will see each one by one, either they are scalar or vector, without of the textbook, or on that of your lesson, you have to identify the vector quantities which holds what? An arrow on its overhead. Then you can identify the symbol of the vector which has what? An arrow on its overhead, which we call it is the vector quantity. So by having this, you have to identify in such a way. Now let's classify here the second question, which is about classifying temperature, volume, velocity, age, weight, and which are what? Vector and scalar. Okay, so by having this, let's do the second question. The second question: force, temperature, volume, velocity, age, weight. So by having this, among this all, which are scalar and which are vector? Okay, which are vector. So by having this, the force is what? The vector quantity. The temperature is scalar. The volume is scalar. The velocity, vector. The age, scalar. Time. Here it is time. Age is time. That we count as a time. Whereas the weight is what? A vector, which is a force. This is a force. Okay? Weight is a force. So by having this, you can identify how the scalar and vectors can be grouped as a quantity. The other thing is, what is the difference between what? In that of the third question, what is the difference between scalar and vector quantities, and why this distinction is significant for understanding physics? In this case, for that of the understanding of physics, here, the difference between scalar and the vectors that we discussed earlier, that the scalars are quantities, only describes what? Magnitude. Only describes magnitude. Whereas vectors describes both magnitude and direction. Both magnitude and what? Direction. In this case, this distinguishing thing is used for analyzing and understanding the phenomena of nature. The phenomena of nature. The phenomena of nature. How we can understand and how we can justify or analyze or describe the nature, the natural effects having that of what? The vector and the scalar quantities. Like for example, distance and displacement. And that of distance and displacement. That the displacement is the shortened The shortest path of what? The shortest path of a given distance. The shortest path of a given distance within a specific direction. Within a specific direction. This means that without a long distance motion, that we use what? The shortest path. Like, for example, the distance and displacement. Like from this point to this point. That's here, this specific direction, the straight line direction, that indicates what? The displacement. Whereas the direction that we use in such a way with independent of direction in different movement, that we call it is what? In different movement, that we call it is the distance. The distance that we only consider about that, our destination, wherever we go. Whereas the displacement considered in a specific direction. In which direction that we can go and take our destination. So by having this is the basic thing to understand what? The nature of physics. By having that of differentiating or distinguishing scalar and vectors. Today's lesson, which is about what? The vector representation. Which is algebraic and geometric form of vector representation. Okay? The algebraic and geometric form of the vector representation. And that of the vector representation, the algebraic form, with that of the vectors, which are represented having that of both magnitude and direction, as we discussed earlier. So the algebraic form, which is described by having that of what? Bold the letter. Within that of the vector quantity, or by putting an arrow on its overhead of the vector. The arrow, here it is, the arrow on it is overhead of the vector quantity. Like that of velocity. Having that of the velocity, which is described by being the symbol of V with an arrow. Force, which has a force as such denotation. Whereas momentum, P with an arrow. Electric field, E with an arrow. In such a way, we can identify the vector algebraically. In some of higher textbook, most of vector quantities which are described by having that of what? Bold letter. አንዳንድ ሪፈረንሶች ወይም ደግሞ ፊዚክስን በምትማሩበት ጊዜ ወደ ላይ ከፍ እያልን ስንሄድ ወይም ደግሞ 11 12 ወይም ወደ ኮሌጅ ወይም ዩኒቨርሲቲ ደረጃ ላይ በምንደርስበት ሰዓት ቬክተር ኳንቲቲዎች አብዛኛው ዲስክራይብ የሚደረጉት በምን ይሆናል? ቦልድ ሌተር ወይም ደግሞ the symbol of the vector which has what? An arrow on its overhead. Then after, without of the geometrical expression of or representation of the vector which is represented by having that of what? Arrows, which is tipped on that of the line segment. Which is having that of the line segment having such a way with initial and final position. For that of the vector. Then the length which is scaled by having that of number. The length that describes what? The magnitude. The length which is what? Magnitude. For example, this length and this length has what? Different value. So by having this, let's say this one is A, and this one is B. So the length, the magnitude of A is greater than magnitude of B. From this, we have what? The magnitude of A is greater than the magnitude of B. In this case, from that of the arrow representation of the vector, we can identify the magnitude by that of what? Its length. So as we discussed, that the tail is a starting point and the head is what? The end point indicating the direction of the vector. That is the very easiest justification. Whereas the direction of the vector shows by that of what? The orientation of the arrow headed. For example, the direction here to that of northeast. with that of the two-dimensional plane form of xy plane, making that of the xy axis, having the east axis here, the positive x axis, the positive y axis, which is the north, and the negative x axis, which is west, and the negative y axis, which is what? Which is south. So by having this, if the given vector, the arrow, which is put like this, then it is found in here, which is what? At the northeast. Like for example here, it's also northeast. But if the direction is directed in the other way, like this, it's found what? Southeast. It's found the southeast. Here A, northeast. Here B, southeast. Whereas here, northwest. Here, southwest. C, D. In such a way, if it is on that of the positive x-axis, east, only east, which is in the positive y-axis, it's only what? North. And in such a way, you can identify either it is north, east, west, and south. So, the components of the vector arrows that we discussed earlier, that is having that of what? The direction, to the head of what? The arrow. The head of the arrow. The head is the final or end, whereas the tail is what? Initial or what? Starting. Whereas the length, which is what? The magnitude. The length, which is what? The magnitude. Length, which is the magnitude of the vector. So, without the representation of the magnitude and direction of vector with its value, the vector-like displacement can express like that of what? S 50 km southwest. Here it is, 50 km southwest, which is drawn like this. 50 km southwest, which is drawn like this. 50 km, like this, to the southwest. Here it is south, here it is what? West. So in this direction, to that of down to what? The southwest. Down to southwest. This region is southwest, this region is northeast, and this region is what? Southeast, and this region is northwest. Okay? By having this, you can determine a given vector. Okay? We have what? The displacement has a magnitude of 50 km. But we also find the direction having that of what? A compass, which is points which help us to specify the vector's orientation. So it's very easy. With that of the other quantities, rather than distance or displacement, with that of the length, we used to have what? The scale. We used to have a scale. The scale that we used to apply a given vector to draw the vector by having that of arrows. Like that of here, 1 centimeter, which equals to what? 1 centimeter is equals to 100 kilometer. Because on that of our drawing or a map system, the real value is different than of what? That of the representation on a paper. So by having this, you have to scale the real value in terms of what? The vector scale. Which determines the amount to be similar. Which is also what we call it is in your mathematics similarity theorem. So by having this, here the scale which we use, for example, 1 centimeter is equals to 2 Newton. If we have 100 Newton, then the scale that we draw like that of 1 centimeter, and that 1 centimeter is equals to 2 Newton, then divide by this 2 Newton, then our drawing shows about what? 50 centimeter. So we have the length which we have what? 50 centimeter. Because we divide 100 Newton by 2. Then the result is what? 50 centimeter. So by a ruler, we draw 50 centimeter. 50 centimeter, which is the same as what? 100 Newton. The force applied, which is what? 100 Newton is the same as 50 centimeter for that of the scale. So for that of 20 Newton force using that of the scale, the arrow would be what? 10 centimeter. Here, for example, for that of 20 Newton, using that of the scale, that we have what? We have the scale of the length, which result is what? 10 centimeter. Only 10 centimeter. If you have a 10 centimeter ruler, then it is easy to draw on your paper. This is also called the mapping system. So, with that of the given scaling, you have to choose an appropriate scale for your vector quantity. Appropriate scale. For example, for that of the scale that you have on that of your ruler, either it is around 10 centimeter or 20 centimeter of ruler, 20 centimeter ruler, you have to choose either it is 1,000 Newton or 1,000,000 Newton. Then you can choose 1 centimeter is the same as what? If you have 1,000,000 Newton, 1 centimeter is the same as what? 1,000 Newton. If you have 1 million, or basically if it is 1 million, if it is 1 million Newton, the force which you have 1 million Newton, then the scale which we have what? 1 centimeter is the same as? 1 centimeter is the same as? Let's say, which is what? 15,000 Newton. Or 15,000 Newton, basically. So when you just divide this, 1 million divided by 15,000, okay? Divided by 50,000, 100 by 5, we have what? The scale, the length of the scale, that's result is the force, which is the same as 20 centimeter. 20 centimeter. In such a way, you can identify the scale of the length of the arrow or the magnitude of the arrow. With that of this scaling, to draw the representation of the vector, you have to follow 3 basic steps. These 3 basic steps. These steps are, the first one is decide what scale that you are used, or what scale you are choose to use. You choose to use, and you have to use the scale to determine what? The length of the arrow, or having that of the calculation. This is a calculation. First of all, choose the scale. Then determine the arrow lengths. Then after, draw what? The arrow without of what? Without the tail to head, by having the scale lengths. By labeling the magnitude of the scale lengths. By labeling the magnitude of the scale lengths, and include the reference direction. At which direction that the represented quantity will be what? Given to. Like that of what we did earlier, like that of the force, which equals to 100 Newton. If 1 centimeter, which equals to 20 Newton. 1 centimeter equals 20 Newton. When you divide this, okay, the length which equals to what? Length is equals to the force per scale. The length of the force. The length of the force with the scale, which is equals to what? 100 Newton divided by 20 Newton in centimeter. Then when you divide it, its result is what? 5 centimeter. Then we have a 5 centimeter length of the scale. Then after this Newton, either it is what? To the northeast. So by having this in the northeast, we have this. Then here it is 5 centimeter. 5 centimeter to that the initial. The force which equals to 5 centimeter, or around what? 100 Newton. 100 Newton to northeast. To the northeast. In such a way, you can draw a simple graphical representation of what? Vector quantities. Simple graphical representation of vector quantities. Let's, for example, draw a vector. Here, 60 kilometers is to scale by indicating the scale that you have to use. So by having this in our solution, first, let's use the scale. Let's use the scale 1 centimeter, which equals to what? 1 centimeter is equals to 4 kilometer. 1 centimeter is equals to 4 kilometer. How much centimeter does 60 kilometer? So we are arranging this, that we have the scale of this, the distance scale to the east, the displacement scale, which is, we have what? 16 kilometer times 1 centimeter divided by what? 4 centimeter due east. Okay, so by having this by 4 we have what? 4 centimeter due east. So we can draw 4 centimeter. Just for example here, 1, 2, 4. Here, 1, 2, 3, 4. 4. Then the arrow is to that of the east. To that of the east. To that of the east. To the east. So by having this, we draw like this. 1, 2, 3, then 4. The arrow is here. So by having this 4 centimeter was the same as what? 16 kilometer due east. So the displacement, which equals to what? 4 centimeter due east, or 60 kilometer due east. So by having this, the displacement, which is 4 centimeter due east, or the displacement, which equals to what? 60 kilometer east. For your representing vector as a displacement. What about the types of vector? What about the types of vector? There are common basic types of vector. Okay, so in this level we'll discuss some of them. The first one is the zero or null vector. As the name indicates, zero or null vector. A null vector is a vector which has what? Which has zero magnitude with no direction. Okay, with no direction. Or the magnitude is zero at any direction. We can call it. That is like that of the resultant of zero. Like that of the resultant vector of zero. Okay, the resultant vector of zero. If the magnitude is zero, then the direction is nothing. Because we have no direction here. Because the result is zero. Then the unit vector. Then the next one is a unit vector, which has the magnitude of what? The magnitude of 1 at any direction, like that of the vector in 2 or 3 dimension. 2 dimension or 3 dimension. Like that of ij. Or the 3 dimension ijk. That are the unit vectors. That are the unit vectors. J. I, which is the 2-dimensional, which is like that of this, the 2-dimension. Ij to that of x-axis and y-axis. Here it is 2-dimension. Or for 3-dimension, or for 3 dimension, we have here for that of a 3-dimensional objects. Or a cubic objects. So we have what? Ijk. So by having this, with that of ijk, which is in 3 dimension, I in that of x-axis, j in that of y-axis, and k in that of z-axis. Here it is, I 1 unit in the x-axis, j 1 unit in the y-axis, and k 1 unit in the z-axis, in the z-axis. In such a way, we have what? A unit vectors. Whereas equal vectors, determine or remembered about the set concept. Equal and equivalent sets. Equal sets are sets which are what? The same number of sets and the same type of sets. Okay, wherever the placement indicates, but without of the number of set and the type of set must be what? The same. In the same thing, equal vectors are vectors. Vectors which have the same magnitude and direction. Both their magnitude of the two or more than two vectors must have what? The same magnitude and also the same direction. The same direction. For example, in equal vectors, if A is in this direction, then A is in this direction, B must be in this direction. Without what? The same length. The same length as what? A. B and A and B as what? The same directions and the same magnitude, the same length. So by having this, we call them what? The equal vectors. We call them equal vectors. And whereas the negative vectors or simply opposite vectors, opposite vectors, which are mainly represent about the forces, opposite forces, like that the force of couples, couple force. The couple force, which are equal and opposite forces, which are applied on a given object or a given thing. Okay, the couple force here F and here minus F and F. Here F and minus F are what? The couple forces. For that of applying torque. You will learn it on grade 11. So by having this to represent the motion of force, that we use what? The negative or opposite vectors. Opposite vectors, where they have what? The same magnitude but opposite in direction. The vectors which has the same magnitude but opposite in direction. A vector A, which is the same as what? Minus A. Which is what? Opposite vector or negative vectors. A vector B, which is the same as minus B, which are opposite or negative vectors. Okay? Negative vectors here, A and A, which are the same length or same magnitude, but different in direction. Opposite in direction. Okay? The reversed direction, which is oriented. So, on this section, on this video, we are learned about how to differentiate the representation of vectors having that of what? An algebraic method, and we represent vectors having that of what? The geometrical method. In that of the algebraic method, that we use what? Either bold the letter of the vector or use that on that of the letter of the vector quantity, that we use an arrow on its overhead. On that of most of the higher physics related books, that you use is what? Uses a bold letter like that of B, which is bolded. Okay? Which is bolded. This is what? Vector. The vector. Or it uses what? B as an arrow. On its overhead. So B is a vector B, which is what? A vector quantity. Which is denoted by algebraically. Whereas without of the geometric method, we represent vector using that of what? The arrow. Having that of the initial and the final position. Initial and final. The starting and end. Without of the start to end, there is what? The length. The length of the arrow, which indicates magnitude. And the final or the head. Here's the head. Indicates direction of what? The vector. Direction of the quantity. In such a way, you can classify the representation of vector as bold or put an arrow on its overhead. On geometrically, you can use an arrow which is drawn on a given vector form. So in this case, we know that the arrow direction, which is on that of the geometric vector, which represents the head, the arrow on its overhead, which represented the vector's orientation. የ1.2 ሪቪው ኮስቲኖችን አብረን እንስራ እስኪ። ስለዚህ የመጀመሪያው the first question is about give an example of a vector stating its magnitude, units and direction. Okay, just we can give two or more than two vector by stating what? By stating its magnitude and what? Units and also direction. Okay, with that of here, this like that of the vector quantity, like that of a vector quantity, like an example, vector quantity, vector of what? Here, A, displacement. The displacement that you take what? 20 kilometer to north. 20 kilometer to north. Okay? B, acceleration. The acceleration of a given body, which is around what? Which is around 4 meters per second square to east or east of north, whatever it is. And C, force, where the force which equals to what? Which equals to 100 Newton north of east. In such a way, you can give different examples, like that of electric field, like that of momentum, like that of magnetic field, and also velocity, and any other. So by having this, you can give a given vector having that of a magnitude 20, okay, a magnitude 20, and the units, here it is kilometer, and the direction is what? North. Whereas here, the acceleration, the magnitude for the unit meter per second square, and the direction east. Whereas the force, the magnitude 100, the unit Newton, and the direction north of east. In such a way, you can give different example. Whereas to that of the second question, choose your own scale and draw arrow to represent the following vector. With that of A, which is 40 kilometer north, and B, 32 meters per second, making an angle of what? 60 degree. So, with that of A, 40 kilometer north, so to the displacement, here, the displacement, which we can have a scale of lengths, which is what? Which result is 1 centimeter is the same as what? Is the same as, let's say 8 kilometer. 1 centimeter is the same as 8 kilometer. So by having this, how much centimeter will be what? 40 kilometer. How much centimeter will be 40 kilometer? Let's take as x. Then rearranging this for that of the vector scale. Then we have x, which is the same as 14 kilometer over 8 kilometer times 1 centimeter. Then this result is what? 5 centimeter. Okay? 5 centimeter. By having this, taking the ruler, then we have the vector scale of this. We have from that of this, then we draw from an initial point, then we have the vector scale like this. So for a north, here we have 1, 2, 3, 4, 5. Okay? Then after, the vector to the north. Here we have, the position here. Then the vector scale, here it is, 1, 2, 3, 4, and what? 5. Then at this point, the vector scale of this, we have 40 kilometer to the north. Or this has a scale of 5 centimeter. The length which has what? 5 centimeter. The magnitude of the scale, which is the same as 5 centimeter, which is what? 40 kilometers to north. 40 kilometers north. In such a way, you can work with what? How the vectors will be identified or calculated using that of the vector scale. B, which is about 32 meters per second, making an angle of 60 degree. Okay, 32 meters per second, an angle of 60 degree. So by having this first, our scale, let's let our scale of the velocity, which is equals 32 meters per second to 60 degree to the horizontal. So by having this, let's the length, which is the same as 1 centimeter, which is again, let's make it 4 centimeter, 4 kilometer. I mean 4 meters per second. Here, 4 meters per second. Then by having this, then how much is 32 meters per second? Then we have, let's add x, calculating this, x is equals to what? 8 meters per second. 8 meters per second, or which is 8 centimeter. 8 centimeter. That's the vectors scaled, which is what? 8 centimeter for 32 meters per second. Then having this, for that of this, we have what? At an angle of 60 degree. Then we have 1, 2, 3, 4, 5, 6, 7, 8. Here. Then this length, which is what? 32 meters per second at 60 degree. Which is the same as what? 8 centimeter length. The scale is what? 1, 2, 3, 4, 5, 6, 7, 8. 8. This is what we call it. The scale is 8 centimeter, whereas the velocity is what? The velocity is 32 meters per second. 32 meters per second to the north east, or 32 meters per second at 60 degree. This is a vector scale. In such a way, you can calculate how you can have what? You can have the drawing of what? The vector scale. I think you get the point. On that, in this next video, we'll discuss about vector addition and subtraction. At the end of this lesson, we will discuss and we will identify how to add or subtract vector. አሁንም እንደ ሁል ጊዜው ዌብሳይታችን lucybridgeacademy.comን መጎብኘት እንዳትረሱ። የዩቲዩብ ፔጃችንን ሰብስክራይብ ማድረግና የቴሌግራም ቻናላችንን እየተቀላቀላችሁ ሐሳብ አስተያየታችሁን አጋሩን። እኔው ነኝ። ደህና ሁኑ።